For our next example, we're asked to let us consider the following 3 points. A, which has coordinates x coordinate 1, y coordinate value 2. B, which has x coordinate 2, y coordinate is 5. C, which has x coordinate of 4, y coordinate of 1. Question asked is, use the distance formula to determine if the triangle is equilateral. This means all sides of equal length. Isosceles, two sides of equal length. And scaling, all sides have different length. So, what the question is effectively asking us to do is think about, well, what are the lengths? What are the lengths of each side? Which means, what is the distance between each 3 points? And then let us compare them and determine whether all those lengths are equal, so that we have an equilateral triangle. 2 of those lengths are equal, in which case we have an isosceles triangle. Or none of those lengths are equal, in which case we have a scalene triangle. So if we wanted to find the length of AB, going back to our formula before, it's equals the square root of the x step. We take this as point number 2, so I have 2 minus 1 plus, all squared, plus 5 minus 2 all squared. This equals the square root of 1 squared plus 3 squared, and this is always a positive value, equals the positive value of 1 plus 9 equals the square root of 10. Now, we can also find the length between points A and C. So this time we'll take C as being the second point. So I'll have the positive square root of 4 minus 1 all squared plus 1 minus 2 all squared. Take the positive square root of everything. Clean up my brackets. This would equal the positive square root, 4 minus 1 is 3 squared, plus minus 1 all squared. This is equal to positive square root of 9 plus, remember, negative times by negative is positive, so that's positive 1 squared. So this is equal to, once again, as we find, the positive square root of 10. So now we have lengths AB and AC. The final length that we need to find, we'll call this length BC. And if we consider that the positive square root, in this case we take C as being the second value, we could have 4 minus 2 all squared plus 1 minus 5 all squared, positive square root value equals positive square root of 2 squared plus 1 minus 5 is minus 4 all squared, I'm taking the square root of it all, equals positive square root of 4 plus, remember, minus times by minus is a positive, so that's minus 4 times by minus 4, which is 16, equals this positive square root of 20. So from determining all the lengths, we can see we have 2 sides have the same value, has a square root of 10, and the third side has a length of square root of 20. then we can say the triangle is isosceles due to AB and AC having